Everyone, welcome to another video. So in today's video I'm gonna cover my approach to the problems that I was able to solve in this November long challenge that took place on CodeChef. Some of the questions are pretty nice because just by looking at the problem we can actually observe some pattern and we can come up with an easy approach. You don't need to know any specific algorithm for it, but we'll see once we go over each problem. Let's start with the first one. So the first problem says that you are provided with X coins and they are worth 1 rupee, and there are Y coins worth rupees 2, right? So now you need to distribute the total sum X plus Y coins into his son such that the value of these coins are same. The number of coins doesn't have to be same, but the value of those coins need to be same, right? So we can actually open our, so um, it's like if we are given 2 and 2, right? So just to explain, so X is 2 and this is Y. So X value of X is 1, right? So if there are two coins of 1, that means I have 2 rupees, and then each value of Y coin is 2 rupees. So if I have two Y coins, then the total value I have is 4 rupees. So in total I have 6 rupees. So I want to know whether I can distribute this into two people or not. From here we can easily distribute it, like each person can get 3, right? So what we can do here is we can distribute Y, give one coin to each person, and then simply give X, each of these X coins to that two sons. So this is the first son, this is the second son, and we can do that. Similarly, we'll see that it's not always possible because, like, let's say in this case 1 and 3 we are not able to distribute, because if I have one coin of X and 3 coins of Y, what is the total sum of this? This is 3 to the 6, because it will be 3 into 2 plus 1, which is like 7. 7 you can never divide between two people, right? And it's not possible by looking here as well. Similarly, 1 and 10 and 4 and 0, 4 and 0 we can distribute because it's like X coins are 4, so you can give 2 coins to the first son, 2 coins to the second son, and it's done. So how can we approach this? Let me take a new screen. So the easiest way, what I did here is I basically checked there can be only 4 cases. Like if my X and Y is like either X is even and Y value is even, right? The number of coins is even for Y, number of coins X is even. So in that case my answer is yes, because obviously I can divide this into two people equally, divide this into two people equally, and I get the correct answer. Similarly, if I have even and odd, let's say in this case can I distribute them equally? We can check. Like, let's say I take the value of X as 2, Y value as odd as 3. So let's say I split 3 max. What I can do is I can give 2 coins to one and first son and 1 coin to second son. So right now the value for this is 2 to the 4, and this is what, 2. So current value for this son is 4 and this son is 2. So this is 2 less, right? Like he needs 2 more coins. So what if I can allot this 2 coins to him? In that case my answer would be, in this case it should be 2 here, and I give 0 coins, so the total becomes 4. So it is possible, right? Like in this case we see that we can actually compensate this with X coins if X is even. But the problem here is we need to make sure that this is not 0, because if it's 0 then we can never divide this equally, right? So yeah, in the other case, other easy case is odd and odd. Obviously odd and odd you can never distribute it. Similarly, if I have odd and even, so in this case also I can never. Why? Because let's take an example. Let's say I have 3 X coins, and I have 2 Y coins. So I can give one Y coin to each son. The value is 2. But what about distributing X? You can never distribute X equally, right? Because one of them will either get 2 and the other will get 1. So this total doesn't match. So this will also never work. So only these 4 cases we need to check, and based on that we can do yes or no. I can show my submission. I think I didn't get right in the first approach, but the second one was right. So yeah, so this is my answer. So as I said, um, as I said, I checked this is even, then it's yes. If it's even odd, in that case I just check that if X is 0 or not. If X is 0, then obviously I cannot fulfill this. Otherwise it's yes. For all the other cases, no. So this was the problem number 1. Let's go to the next problem. Weird palindrome matching. So let me take a new page here. Okay. Naveed is a tribe that speaks some weird language. The alphabet consists of n distinct characters. Here's an array. Okay, so in this problem, now I can recall what this problem is about. In this problem, what we need to do here is we are given some letters, count of each character that occurs in the language. So for example, let's take this case 431. So the case here is that I have maybe 4, let's say 3 1. So I have 4 letters of A, I have 3 letters of B, and I have 1 letter of C. Suppose this is the case. So what we need to do here is we need to make a palindrome using all these letters. So I have to use A 4 times, B 3 times, C 1 time. What we can observe here is we are given some cases. So in order to make this possible, he can perform the following operation. Select an I and convert all occurrence of the ith alphabet to any other alphabet of his choice, right? So you can see here we cannot never form a palindrome with these numbers, because let's say if A is even, so A is fine, that A can occur on both the sides. Like if palindrome is like if we partition the string into half, we can easily have two matching pairs on left and right side. But what about B? I can have one B here, but then this B and this C won't match, so it's not a palindrome. So what if I can change this C to B, as it said, right? I can convert all occurrence of one alphabet to the other alphabet. So this basically makes my string palindrome. And because I'm using this operation once, like I'm basically either I can change all B to C, or I can change all C to B. It's same, so it is counted as one operation. So in this case my operation is 1, right? So that only we have to find that how many operations I will take in order to fulfill this. Again, the easiest way, if you see the observe the problem clearly, what happens is, let's say the total count, initially the total count, suppose either total count can be even or odd, right? So like total count of all the characters being even or odd. So if it's even, like if all the counts are even of all the characters, then there is one case where either all characters count of each character's letter is also even. So in that case I have 0 operations. But what if for some characters, like in this case if you see, the total is 4 plus 3, it's 7 plus 1 8. So it's 8 is sum is even, but still we cannot form by without doing the operation. So in this case what we can do, we need to see the count of letters having odd count. It should be even, right? Count of odd letters, count of count of letters being odd, actually like this, count of letters being odd should be even, because if it's even, then only our answer would be even divided by 2, because we are forming pairs. we need to form pairs, and that will be our answer in this case. Now let's come to the odd case. In odd case, what will happen? Odd case, zero operations will only happen if except one letter, like the case like this. Let's say if I have 4 2 1. So in this case, I actually can keep this as a center, right? In odd, what I can do, I can keep a C here, then I have BB here, then A. This is a palindrome. So in this case, what will happen? The number of operations will be 0 if only one letter count is odd, all else every other letter has even count. So in this case, answer would be 0. The other case would be again same, right? Like this. So what we need to do here is we need to only count the number of odd odd number of characters having odd count. Once we have that count, right? Once we have that count, let's say I have like this 4. Let me take 3, 7, 5. So what we can do here is, because the length is odd, we can actually ignore this, because this can act as a center, right? Like one letter from this can act as a center, so the remaining is 4. So we can balance this out on the left and right, and we can interchange these two pairs among each other. So here what we need to do, we just do the count minus 1 by 2, and count here is the number of letters having odd count. Here we directly do count divided by 2, and that's our answer. So hope this makes sense. We can look at the code. Yeah, so what I did here was I actually checked, I actually only add the number of letters having odd, even you can say odd count, and then what I do, I check whether what is the sum, is it odd or even. So this is the case of odd sum. So in odd sum, what I did here is, as I told you, count minus 1, right? I did here count minus 1 divided by 2, and this is what I do here. In the even case, what I do, if it's again, I don't need to do subtract, I can directly do count divided by 2, right? If it's greater than 0, then I directly do this, else I print 0, and then this is my answer. Hope it makes sense. Let's move on to the third one. Okay, so let me remove this. So in this question also we need observation. So what they are saying is, you are given a array of numbers, and you need to either form that sequence strictly increasing, like this 1 2 3. This is strictly increasing. 1 2 2 3 is not considered strictly increasing. Similarly, we can do it completely decreasing, 3 2 1. So this is correct, this is correct. And the third approach is, there exists only one index, like something like this. So there is only one local maxima, like you can think of it as like a mountain, a hill, and then this is the correct. This is not considered correct, like something like this, 1 2 3 2, and then 1, and then 2, and then 3 again, and then 2 1. So here it's like going up, increasing, then it's going down, it's going up, it's going down. So this is forming. This is not right. We only need one clean peak, like before it's increasing, and then after it's decreasing. So hope this makes sense. We only need to form this. So what we need to tell them is, if it's possible, what is the correct sequence using the array values, else if it's not possible to form any of these three conditions, we print -1. So the easiest observation here would be that first we need to check that if the array only has unique elements, right? And one more condition I forgot to say, you need to print the lexicographically largest one. That means the sequence which is strictly decreasing will always be lexicographically largest, right? Because in that case the larger number comes at the front, and that is what we mean by lexicographically largest. So what we can do, if case 1 is all elements, sorry for my handwriting, are unique. So in that case, just sort in decreasing order, right? The other cases we have duplicates, right? In that case, if any number has more than two duplicates, like for example, if our array has 1 2 2 2 3, then our answers will be -1, clearly -1 if we have greater than two duplicates. Why? Because let's say if I want to form a lexicographically smallest sorry, largest sequence. So in that case, let's try to form a mountain because I have duplicates, right? So I need to form a hill kind of a structure. So what I can do, I can do like this, completely decreasing, increasing, and then decreasing. So this is one valid answer. But what about the extra two? Like if I put an extra two here, or I need to put the two here, right? Because it has to be either completely increasing or decreasing. So this is not valid because in this case it's not strictly increasing or decreasing. So if this is the observation, that if any of the numbers has more than two count, right, then the answer is -1, clearly. Now once all these cases are not there, there is a third case which can happen. The third case would be that some number has two duplicates, max to max two duplicates of it. So in that case, what we can do, the numbers which have more than one duplicate, right, which have count more than one, we can actually store them in an array and we can print them. Like what we can do, let's say I have a sequence like this: 1 2 2 5 5. Oh yeah, there is one more case. The largest number cannot have count more than one. Like let's say I'll show you. Like in this case, if my sequence is like this is wrong, because if my largest number is having more than one count, then there won't be any peak, because after that number 3 will come here again, and which is wrong. So this is also one more condition, that max count should be less than equal to 1. This will also give me -1. Now once these three cases are not there, we can consider this case where I have, let's take this 7. This is 7, yeah. So in this case, what I can do, I can see that 5 and 2 are like coming twice. So I can actually print 2 5 7 5 2 1. So the unique, the all the unique values, which if I remove duplicates, whatever is left, I'll just print them in the sorting order, descending order. And if any duplicates come, which is like count is equal to 2, right, because it cannot be more than 2, and the max value obviously doesn't have count more than 1. So in that case, I'll just print them in increasing order. So this is gonna form a hill kind of structure, and that is our answer. Hope this makes sense. We can check the submission for this. So what I do here is, I basically take the input, and then I check that if the max has count more than 1, then it's -1, clearly. Else in the other case, what I check, if any other number has count greater than 2, so that is -1. Now these two cases are covered, so that means we can form a valid sequence. So I create two arrays, vectors, unique and duplicates. I push all the unique into one, I push all the duplicates into one, and then I just sort them, and then I print the duplicates first in the ascending order, and then I print unique in the descending order. And that is it for this question. Let's go to the next one. So yeah, so in this case, what we need to do here is, this is a very nice question. It is, I think this is for the graph. Yeah, okay, 1000 people were able to solve. Yeah, so that means it's pretty self-explanatory, but I'll go over it. So we are given two values, n and m. So we are given n as in the number of vertices that are in a graph, and m as in number of edges, and we have to make sure that the increases, yes, and the graph is fully connected. It says any connected unguided graph, so that means that all nodes are part of one graph. You don't have any other graph. And it says that you need to form a graph so such that the count of bridge is less. So it's more, sorry, it's more maximum. What is a bridge? So for example, I have a graph like 1, 2, 3. So in that case, these two are the bridges. Why? Because if I remove this edge, then it forms this as one graph and this as one graph, so it's creating more graph. So any edge removing which creates more components is considered a bridge. Simple as that. Now you are given n and m, and you need to form like a graph. You need to give them like like the pairs of edges, such that the graph formed using the edge pair has maximum bridges, right? A bridge, yeah, number of bridges is maximized. Okay, so let's take an example. um, so here let's say n is 4 and m is 4. Also there is need to one more thing to consider here is this m constraint has to be between n minus 1 and n into n minus. Why? Because if the graph has to be connected, so if there are 4 edges, right, so the minimum you can do here is you can connect them in a tree form, and it needs, if you see, for 4 edge it needs n minus 1 for 4 vertices it needs n minus 1 edges, that is, it needs 3 edges. So 3 is the minimum value that will be provided to us in the test case, like a valid test case. So all the test cases are valid, and then the maximum you can form is, let's say, if every node has a edge to the other node, like one is with 2, one has with 3, one has with 4, then 2 has with 3, 2 has with 4, and then it's done. So how many edges are there now? 1, 2, 3, 4, 5, 6. So what is 6? So we have 4 into 3 by 2, right? So which is 6. So in this case the number m will always be between 3 and 6. Like, that is proven, like we don't need to worry about it. So it's going to be a valid one. Now what I my approach was here, that let me remove this again. And so my approach here was, I basically created, by default I would need m minus 1 edges, right? So I would just print like alternate pairs I and I plus 1. So 1 and 2, 2 and 3, 3 and 4. Once that is done, I'm given an input m, right, and base, and I need to create a graph such that it has m edges and the number of bridges is maximized. So what I did, I clearly subtract this value. So I did like m minus equal to n minus 1 initially, and I just printed these pairs for now. Now I'm left over with some m edges that I need to create. So I created a while loop, and then I did while m is greater than 0, obviously. So if initially m given was equal to n minus 1, then it won't go inside the while loop. Now what I did, like let's say I'm given n as 4 and m as 6. So what I did greedily was that these are connected now in order, and all of these are bridges for now, right? Like if I remove this, it will be a separate component. If I remove this, separate component. If I remove this, it will split the graph. So what I did, if greedily I try to maximize the number of edges for each node, like let's say now I need to reach 6, right, and I already have created 3. So what is the leftover edges that I need to create? I need to create m equal to 3 edges, 3 more edges. Now, or let's take m as 5, it will be easy. So I need to create 2 more edges. What I did greedily was, one already has a pair edge with 2, I created one with 3, right? And then I created one with, so I think this is done. I actually need to create one with, oh sorry, let's take m as 4. Actually that is more easy. So I have one edge left. So I greedily created one edge with 3. Now I have 4 edges and I still have maximum number of bridges left is 1. If my m value was 5, there is no way I would have any bridge in the graph, because I would need to greedily create an edge between 1 and 4, and that will like bring my bridge count to 0, because if I remove this edge also, my whole graph is connected, right? Like you can reach 4 from some other graph, some other edge, vertices. Similarly, if my m was 6, then there is only one edge left, which is like 3 and 4, right? So what I did here is, I can take another example as 1, 2, 3, 4 and 5. So what I did here is, if my n is 5 and if my n is was given, let's say 6, so I already created 4 edges, so my leftover m now is 2. I need to create 2 more edges, so I greedily created one edge from 1 to 3, right? And then I greedily created one edge from 1 to 4, ignoring the 5 part, because I'm trying to minimize my reach till the end node. I'm trying to maximize the number of edges from the first node. Now if my m was 7, that is, I need to create one more edge, then I cannot do anything, and I needed to create a edge from 1 to 5. I mean, that is what max I can do, right? So I think this was, oh no, sorry, my bad. So in this case, what I did here was, if my m was 7, I basically tried to create edge between 2 and 4, like, because this is a part of a connected graph already. I try to avoid going to 5 unless it's required. So because creating an edge with 1 and 4 already brings 4 into this, strongly connected component, creating an edge between 2 and 4 actually helps, because if I create between 1 and 5 instead of 2 and 4, like when the m is 7, then in that case my bridge count becomes 0. But if you see this graph has m equal to 7 and the number of bridges is still 1, right? So this makes more sense to me. If I had m is equal to 8, yeah, in that case I cannot do anything, and then I needed to include this 5 as well. I have to create a edge between these two nodes. So I think the code will help in this case. What I did here was, I created, as I said, I created edges between I and I plus 1, because it's as a tree, and I subtracted n minus 1 edges already from m. Now and this started with 1 and 3, right? And what I did here was, because if you see, I and I plus 1 already have an edge, so it makes sense to actually create an edge between 1 and if my end is 3, so it makes sense to create an edge between these two. Once that difference between them is equal to 2, then I move to the next part, which is my start will become 2, and I'll increase my end to 4. So I do that. If my while end this minus 2 is equal to start, then in that case I break, I come out of this while loop. Else I was just implementing incrementing start, then I increment the end, and then I greedily create this edges, as I told here, like 1 to 3. Once this condition is met, that okay, 1 end minus 2, like 3 minus 2 is equal to 1, then in that case I come out of this, and I need to increase my end, so end becomes 4. Now I start again, like creating a edge between 1 and 2, and in next case I create an edge between 2 and 4. Now for 2 and 4 this condition is met, and then I again break up. So I think the greedy approach here worked best for me. Let's go to the other part, the Xor question. This was an interesting one. It took many hours for me to figure out what exactly I can do. So the case here is, you are given an array like 2, 4, 5. You need to find the smallest number x, any number, which adding to each element, like you need to add some x to 2, like let's say I add 1 to 2, then I add 1 to 4, and then I add 1 to 5. And then when I take Xor of this 3, 5, 6, it should be equal to 0, right? So it needed some bitwise observation, but the easiest observation that I saw was, let's write everything in bitwise. 0, 1, 0 for 2, for 4 it will be 1, 0, 0, and then for 5 it will be 1, 0, 1. So my final answer, I need a 0, right? So 0 has this in the binary. What I observed was, in case of Xor, any order, if the number of ones in any bit is even, automatically the answer will be 0. Let's say I have 1 0 1. So in this case, 1 and 0 Xor will give me 1, and then 1 and 1 Xor will give me 0. So what I saw here was, when I did a Xor between 2, 4 and 5, I saw that this bit will give me 1, this bit was giving me 1, and this bit was giving me 0. So and we need to actually find the minimum number. So it made sense to me that what if I started adding one value bit to from the end. So once I did that, like you can see, this became 0, and adding this one bit basically gives me 1 0. Basically it's a 10, so 1 0, and then it's 1 and 1, and then it became 0 here, and then similarly it became 0 here. So what I did basically was, I checked from left to right bitwise, and anywhere I found that the number of ones is not even, I would actually add bitwise shift of that I to that value. Because what happens, let's say my number was something like 0 1 0 and 0 0 0. Just an example, I know this is not a correct answer. What I'm trying to show here is, this is already 0, but here we see the number of one bit is not even. So what I do here is, you need to add 1 here, but adding 1 to this place means adding 2 in the decimal format, right? Because this is what, 0 1 2, so this is like 2 to the power 1 we are adding here. So you need to make sure that your final answer, you need to give in decimal, not binary. So you need to actually, whenever you are adding this one bit to any of this bit position, you need to make sure you do a bitwise shift, left shift, and then add it to your answer. Maybe I can show my code. Oops, sorry. My submissions. And what I did here was, I basically took 1 and 0, and then I just calculated number of, so I, obviously it was a large number, I guess. Let me open this. It was yeah, this numbers was very high, so I used 64 bits. I thought 32 won't work, so I started with 64. So for each bit from left to right, for each number, array number, I ran through it. I did a bitwise, like whichever was set, and then if it was set to 1, and if it odd, like in case this is odd, what I did here was, I actually started adding that bit value, which is like, I start with the 1, and then I added that to the each array, and then I saved, and then, as I said, I added this to the result. In this case, I think here, as I said, this part is happening. Like if I'm adding it to the first bit, if I'm adding to the second bit, I need to do this shift as well. So this shift happens on each loop, because I'm moving from left to right. So it's pretty self-explanatory, but yeah, this is what I'm doing. If I find it odd, I basically make sure to add that bit to the result, and I move each bit in my array by that value, and that's how I ended up with the correct answer. Now moving on to the last, this was the last part I was able to solve. This also took a lot of time, but it was about a simple observation. What I did here was, if you see, the question says clearly that whatever you are given an S as a valid string, and as well as the L and R that they provide, that will also constitute to a valid string. So in this case, you don't have to worry that it's a valid or not. So what I did here was, I took basically 3 stacks. One stack for keeping track of open brackets, I call them brackets. One stack to keep a pair, I'll show you what I keep pair for, and then I kept this one for my operator. So what I did here was, let's take this example, bracket and let's give its number as 1 2. This is the index values 3 4 5 6 7 8 9. Now what I did, when I saw the first bracket, I would add 1 to the bracket, right? And then I would add nothing to the pair, and the operator also has nothing. Now I get a question mark. So for question mark, what happens, you saw in the question that we can only replace question with either 1 and 0. So in that case, what I did here was, a question mark can either take 1 or 0. So I am basically storing the max and min value expression can take. Right now my expression is just this question mark, right? What I do here is, there could be a query where you only have question mark. So I basically created a map. I'm creating a data structure where I keep that 2 comma 2, the max value is 1, because we need to return the maximum value that expression can take, right, for L and R. So 2 comma 2 is 1. In short, if my query has 2 comma 2 like this, I can just check my map saying, okay, is the map has the entry, because we know that the expression is going to be valid. So we can be confident that our map will contain that answer and we can store it. Let's move forward. Now when I get minus, I add it to the operator minus, right? Then I get another question mark, I add 4 here, and then not question mark, bracket, and then I get another question mark. So in this case, the question mark again. So this could also happen that some query has 5 comma 5. So I add 1 to here, and then I add 1 comma 0 here. Now I get plus. So I add plus to here. Now I again get a bracket. I add 7 comma 7 to my map, a global map you can think, and I store 1, and I add my pair value, that this question mark is taking 1 comma 0. Now here is the catchy part. As soon as I get a closing bracket, I know that some valid expression has come to an end. So in that case, I pop from the operator, I pop from the pair, I pop 2 values from the pair, because I know this operator comes in between 2 of the valid question marks or whatever. So I pop 2 of these values. Now I calculate. So I have 1 comma 0, I have 1 comma 0, right? Let's say this is S1, this is S2, like this is S1 and S2. So what happens here is, I need to calculate the maximum value. So this is a plus sign. So plus sign, what could be the maximum value? Maximum value will be if I add maximum of these two, right, which is like 1 plus 1, which is like 2, and minimum value would be if I add minimum of these, which is 0 0, which is like 0 plus 0, which is 0. So what I do here is, and I also got this closing bracket at 8. So I make sure that when I'm popping from the brackets, I basically pop this value from the bracket, I am popping this value from the bracket. So it's gone. Let me remove this. Yeah, and then I store 4 comma 8, and I store the maximum value, which will be 2 for this expression, right? And I basically, as I said, I had popped these 2 values, right? But I would basically insert this value 2 comma 0 that I calculated as maximum value, because I don't know if there are other expressions that I need to evaluate. Now we'll come to that part. Now when I get this another closing bracket, I basically pop this minus sign, and I pop this 1, and I start storing this 1 comma 9 in my unordered map. And the way I do is, and then I pop these 2 values, as I said, right? So I pop these 2 values. Now these 2 values will be 2 comma 0 and 1 comma 0. So we see there is a minus operator. So in case of minus operator, what is the maximum value I will get? Doesn't it make sense that if I take the maximum of the left side, which is in our case the left side will be this part, because the lower part, the bottommost part, comes on the left side. So doesn't it make sense if I do maximum of this subtract minimum of this? That will give me the maximum value na, in case of subtraction. So I will do my 1 minus 0 to get the max, and the way I will get min would be if I subtract this minimum of this, which is 0, and I subtract this with the maximum of whatever it is, that is the minimum value I can get. So my pair, that form will be 1 comma minus 2, and then I will insert 1 comma minus 2 here, And I will be storing 1 here because 1 is the maximum value that I get for 1 and 9. So what I do with this, my string operation has ended. I have traversed through the string. My bracket stack will be empty because it's a valid string that will be given. Operator stack will be empty, and pair stack will have this value, which actually we don't care now because we already have formed answer for our queries. Now we can just take the query as an input, run the query loop, take the IL and R as input, and because we know that L and R are going to be valid always, we know that some one of these queries will be asked, and that's how we solve it. I can show you my submissions. So yeah, it's little dirty, but this is what I'm doing with the 3 stacks which I showed you. And then once this is done, I just query and just I return it. It's pretty straightforward to observe. Like you can do it in OFN time. um, but yeah, that's all I was able to solve. I didn't get time to I checked this part question. None of the approaches clicked me, so I ignored this question, and then these other two I actually didn't check. Maybe I'll check the editorial, and I'll learn something new. But yeah, this long challenge actually is good because I can devote 2 to 3 hours or maybe 4 hours to each question, and then I can come up with the approach. Because I'm not too fast in coming up with approaches. I'm not good at competitive programming, but I just do this for fun. Hope you guys learned something new, and I'll keep sharing more videos like this. If you like this video, please subscribe to my channel and give me a thumbs up. Thanks everyone.